is supposed to be weird in my HO or HA.
HO?
Yeah, HO. So my HO has greater than or equal to. And HA is the opposite of my HO, which is last one. However, what is my first part of this expression? So we're trying to find the sample average, which is a mu question, right? It's not P, it's a mu question. And then, what is the order? The order is Boston minus Boston. So I have mu Boston minus mu Boston. Well, what is my hypothesis? What is the value that I am given to pass? Am I given any number? No. I am not given any number. So that is the first way, how can I tell my hypothesis value is 0? Besides that, I have another way. It says the mean number of Boston. So the mean number of Boston is greater than or equal to the mean number of Buffalo. So if I move my mu Buffalo to the left hand side, what do I have? I have mu Boston minus mu Buffalo. You know what I have on the right side of the equation? I have 0. Yes, that is the second way. How can I tell my hypothesis value is 0? But on your exam, you don't have to prove this, right? If you're not given any number, that means your hypothesis value is 0. That's it. You can start your problem. Right. Step 2, I am asked to find the critical value. In this case, am I supposed to use Z crit or T crit? T crit. Why is T crit? The population standard deviation, which is sigma, is not given. So some student asked me yesterday, what does this S mean? S equals 8.9, S equals 7.4. Those S's are sample standard deviation. That doesn't mean sigma is given. Sigma means population standard deviation. If that is the case, we have to use the T table instead of Z table. So I have the Z T crit because I have a lower tail pass right here, last n. So my T crit has to be negative, exactly. And how can I get my T crit? What is my n? And what is my EF? And what is my alpha? So before we go to the T table, we have to have EF and alpha. So in this case, what is the formula? The formula that I am supposed to follow with to get my EF. We have n minus 1, n minus 2, a very long EF formula. We have n1 plus n2 minus 2. So how can I tell which is which? Which one am I supposed to have in this case? What? Yeah. Yeah. I will say, in this case, you're supposed to use the scary DF formula, which is the longest one. And how can I tell? All right, we don't have any specific thing telling you you have to use that one. But you have to ask yourself, is that a equivariance? Is that a proportion question? You have to ask yourself, and then, right? Okay, let's focus on this question. So my first question for myself is, do I have equivariance in this question? No. I don't have equivariance. Okay. So the equal variance, I have n1 plus n2 minus 2, right? What is my second special case? Are they dependent samples, right? Are they dependent? If that is the case, what is my df?
N1 plus N.
Minus 1 or 2?
1.
1? Okay. Is that true? Yeah, that is correct. Alright, so
Dependent.
I'm not given 2 dependent samples because Buffalo and Boston are independent, right? Those are 2 independent cities. Am I given any equivariance word in my question? No. So if that is the case, right, the only formula that you can use is the scary df. What is my scary df? S1 squared over n1, S2 squared over n2, sum them up, squared it, S1 squared n1 squared it, divided by n1 minus 1 plus S2 squared over n1 squared it over n2 minus 1. And I'm going to tell you guys how to use this formula to get your scary df within 30 seconds. 30 seconds. All right. So the first step is I have to analyze this formula. Right? So what is my top number? I have my top number is S1 squared over n1. I have S2 squared over n2. What is my bottom number? I still have these 2 guys, right? But in a different form, right? On the top, we add these 2 guys together and squared it. On the bottom, we squared each guys and divided by the sample space minus 1, right? So basically, we have these 2 guys on the top and bottom. And now, how can I deal with it? I will say, assume this is my A, and that is my B. I will store it. I stow 1, stow 2. What is my stow 1? My stow 1 is S squared, S1 squared over N1. What is my S1 squared? 8.9. 8.9 squared divided by N1, which is 59. I store it. This is my stow 1. What is my stow 2? 7.4 squared divided by 32. That is my stow 2. Right? I have my stow 1 and my stow 2. Right? What is my numerator of this scary df? I have stow 1 plus stow 2 squared the sum of these 2 guys. Right? So now I'm going to recall 1 plus recall 2. What is that? Recall 1 plus recall 2. I got 3.05. Is that number you got? Okay. And then I squared it. I got 9.3256. So 9.3256 is my top number. It's my numerator. So I stole 3. I stole 3. Store it? Okay. Now, what is my bottom number? My bottom number is actually a squared over n1 minus 1 plus b squared over n2 minus 1. Does it make sense?
Yes.
Okay, what is my a squared? I recall 1. This is my a. Now this time, I need to square it. I squared it, and then divide by n1 minus 1, which is 58, right? Which is 58. I divided by 58. Okay, so this guy equals 0.0310. Now this is my new store 1 because I don't need this guy anymore. I stored it, store 1. This is my new store 1. What is my second part? Now I recall 2, which is my b. I squared it. I got 2.928 divided by n2 minus 1, which is 31. Okay, I got 0.0446. Now this is my new store 2. Store 2. Because I don't use my b anymore. So I can cover this guy by this guy. Now, what is my stove 3? My top number. My stove 3 is the top number. What is this? This is my new store 1. This is my new store 1. That is my new store 2.